Hello everyone, in this video we are going to discuss the solution of engineering mathematics questions from GATE 2021 Aerospace Engineering Department. I discuss only mathematics questions from GATE 2021 Aerospace Engineering Department question. Totally 8 questions have been asked from engineering mathematics topic. Now let's move on to the first problem. Let's start with this problem. The problem is consider the differential equation. One differential equation is given and the boundary conditions also given, y of 0 equal to 1 and y dash of 0 equal to 0. The solution to this equation is, the given equation is second order ordinary differential equation with constant coefficients, and it is also homogeneous because right hand side is 0, this part is 0, so this equation is homogeneous second order ordinary differential equation. The general solution of second order ordinary differential equation is y equal to complementary function plus particular integral. Here the given equation is homogeneous, so the solution y equal to CF only. So you have to find CF only. Now let us find the CF. How to find CF? First I write the auxiliary equation. What is auxiliary equation? M square plus 8m plus 16 equal to 0. Solve this quadratic equation. I got two roots, that is m equal to minus 4 minus 4. Roots are real and equal. The formula is here. Roots are real and equal. Two roots. It is quadratic equation. I got two roots. So complementary function, that is y equal to c1x plus c2 into e power m1x. m1 equal to m2, so m1x. So the solution y of x equal to c1x plus c2 e power minus 4x. Here m value is minus 4. This is the solution. Now you have to find the value of c1 and c2 by using that boundary conditions. Y of 0 equal to 1 and y dash of 0 equal to 0. Now y of 0 equal to 1 gives 1 equal to c2. So c2 value is 1. Next, y dash of 0 equal to 0. So I find y dash of x. How to find y dash of x? First I write e power minus 4x. Next I differentiate this part. I got c1 plus I write this part c1x plus c2, differentiation of e power minus 4x. That is, if differentiation of e power minus 4x minus 4 e power minus 4x into c1x plus c2. Now substitute that condition. Y dash of 0 equal to 0 gives 0 equal to C1 minus 4C2. C1 minus 4C2. So C1 equal to 4C2. C2 is 1. C1 equal to 4. Finally, I got C1 and C2. Substitute C1 and C2 value in the solution. That is y of x equal to 4x plus 1. C1 is 4. C2 is 1. E power minus 4x. So the answer is 1 plus 4x into e power minus 4x. Option 3 is the correct answer. Now let's move on to the next problem. Given that C is the unit circle in the counterclockwise direction with its center at origin, the integral value is what? You have to find this integral value. This problem can be solved by using two methods. One is Cauchy residue formula, another one is Cauchy integral formula. Here I am going to solve this problem by using Cauchy residue theorem. You can also use Cauchy integral formula. First I explain what is Cauchy residue theorem. If f of z is analytic on and inside a simple closed curve C, except for a finite number of singularities a1, a2, etc. an lying inside C, and R1, R2, etc. Rn are the residue of f of z at these singularities a1, a2, etc. an respectively, then integral f of z dz equal to 2 pi I into R1 plus R2 plus etc. Rn. Sum of the residues into 2 pi I, that is the value of integral f of z dz. First I find the singularities. Here the value f of z is z cube by 4z minus I. So I take it 4 outside, I got z minus I by 4. How to get singularities, the denominator value is equal to 0. In what value of z, the denominator value is 0. That is z minus I by 4. So z equal to I by 4. Z equal to I by 4 is a singular point. Next, you have to check it is inside the curve C or outside. What is the curve? It is the unit circle in the counterclockwise direction with its center at origin. Unit circle, so this is 1, this is minus 1, this is the circle. It is the circle, radius is 1 and center is origin. So z equal to I by 4. What is the point of z equal to I by 4? 0, 1 by 4. 0, 1 by 4. This point is lies here. 0, 1 by 4 is lies here. Okay. So this singularity is inside the circle. Inside the circle. So you have to write integral f of z. F of z what? Z cube by 4 into z minus I by 4. dz equal to 2 pi I into residue of f of z at z equal to I by 4. So next you have to find residue of f of z at z equal to I by 4. What is the residue of f of z formula at z equal to a? Is limit z tends to a. Here a value is I by 4, so I substitute the value of a is I by 4. Z minus a is I by 4, z minus I by 4 into f of z. What is the value of f of z? Z cube by 4 into z minus I by 4. Cancel z minus I by 4, z minus I by 4. Finally, I got z cube by 4. Substitute the value of I by 4. Limit of z cube by 4 is I cube by 4 power 4, because this is 1 4 and 4. 4 cube and this one 4. Okay, 4 power 4. This is the residue value. So the integral value is, I write here, this is equal to 2 pi I into I cube by 4 power 4. I cube into I is I power 4. I power 4 value is 1. 2 pi by 4 power 4 value is 0.024555, etc. So finally I got the value of 0.025. Round off to 3 decimal places. So 0.025. This is the final answer. Next problem. Consider the velocity field V vector equal to one vector field is given. It is two-dimensional vector field. The field V vector is divergent free or curl free, etc. So you have to check it is divergent free and curl free. Okay. The definition of divergent free is the vector field V vector satisfies del vector dot V vector equal to 0, then it is said to be divergent free. Similarly, the vector field V vector is satisfy del vector del dot cross V vector equal to 0, then it is said to be, this V vector is said to be curl free. This is the definition of divergent free and curl free. Divergent free, it is also called solenoidal vector, and curl free, it is also called irrotational vector. Next, I check first divergent free. Del dot V vector. Del is vector operator I by dou x, I vector dou by dou x, j vector dou by dot V vector. What is the V vector? 2x plus 3y I vector plus 3x plus 2y j vector. Now dot product of two vector is I dot I is 1, dou by dou x of this part is 2. This is 0, this is 2x is 2. Plus j dot j is 1, so dou by dou y of this part, that is also 2. Finally I got 4. It is not equal to 0. So V vector is not divergent free. So V vector is not divergent free. Next you have to check curl free. Del cross V vector. But the curl operation only applicable to three-dimensional vector. But the definition of curl is curl measure the rotation in a vector field. In a two-dimensional, if a vector field is given by the function V vector is, suppose v1 I vector plus v2 j vector. v1 and v2 are is a function of x and y. v also function of x and y. So the rotation is given by the formula in 2D, two-dimensional, is curl v vector. That is rotation, or in a vector field is the measure, curl measure the rotation in a vector field. So the formula of rotation in a two-dimensional is dou v2 by dou x minus dou v1 by dou y. This is the formula of curl v vector in two-dimensional vector field. So here v1 is this one, v2 is this one. Dou v2 by dou x, that is 3, minus dou v1 by dou y, this is also 3, but here one minus is available, 0. So finally I got curl v vector equal to 0. So it is curl free but not divergent free. It is curl free but not divergent free. So the final answer is option 4. Next, fourth problem. U of x comma y is governed by the following equation. It is the partial differential equation, second order partial differential equation. The nature of this equation is, here I explain how to find the nature of one partial differential equation. This is the general form of partial differential equation, second order. AUXX, that is dou square u by dou x square, plus this one is dou square u by dou x dou y, CUYY plus DUX EUY plus H equal to 0. This is the general form. It is satisfies this condition, b square minus 4ac is greater than 0, then this equation is said to be hyperbolic. This PDE is said to be hyperbolic. B square minus 4ac is less than 0, then it is said to be elliptic. B square minus 4ac equal to 0, then it is said to be parabolic. So first, the given partial differential equation is this one. Here a equal to uxx coefficient, that is 1. B equal to uxy coefficient, this is minus 4. C equal to uyy coefficient, this is 6. Next I find b square minus 4ac, this is 16 minus 4ac. 4 6 are 24. Finally I got minus 8, this is less than 0, then so it is elliptic. This equation, the nature of this partial differential equation is elliptic. Option 1 is the correct answer. Next problem. Limit x tends to 0, 1 by sin x minus 1 by x equal to what? Rounded off to nearest integer. Okay. First, I substitute the limit x tends to 0. I got, what is the value? 1 by 0 minus 1 by 0. Infinity minus infinity form. Infinity minus infinity form. So, you have to change this form into 0 by 0 form. So, I take the LCM, limit x tends to 0. The LCM of this term is x sin x. So, I got the numerator is x minus sin x. Now I substitute the limit, I got 0 by 0 form. 0 by 0 form. So in this place I use L'Hospital rule. L'Hospital rule says, suppose you got the form 0 by 0 or infinity by infinity, it is indeterminate form. So you, in this case we have limit x tends to a f of x by g of x equal to limit x tends to a f dash of x by g dash of x. This is the L'Hospital rule. So in this step, I use L'Hospital rule, that is limit x tends to 0, differentiation of x minus sin x is 1 minus cos x divided by differentiation of this part is x cos x plus sin x. Okay, separately differentiate numerator and denominator. Next, I substitute the limit. I got again 0 by 0. 1 minus cos 0 also 1, 0 divided by here 0 plus 0, so 0. 0 by 0 form. So, one more time I apply L'Hospital rule. That is, one differentiation of 1 is 0 minus cos x is sin x divided by differentiation of denominator is minus x sin x plus cos x, differentiation of x is 1 plus differentiation of sin x is cos x. Finally, I got this value is 0 by 2. So 0. The limit of this function, limit of x tends to 0, 1 by sin x minus 1 by x equal to 0. So the final answer is 0. Next, sixth problem. The definite integral 1 to 5 x square dx is evaluated using 4 equal intervals by two methods. First one is trapezoidal rule and then by Simpson's 1/3 rule. The absolute value of the difference between the two calculations. Okay, rounded off to decimal places. First, the definite integral, one integral value is given. Next, the using four equal intervals. Number of interval is 4. We have to find the value of interval h equal to b minus a by n. b is upper limit 5, a is lower limit 1, n is 4. So finally I got h value is 1. So I found the table first. I find the table. X is start with 1 and the interval value is 1. So 2, 3, 4, 5. I got the 4 intervals. The interval value h equal to 1. Corresponding y equal to x square. That is, here the function integrand is x square. So y equal to x square 1, 4, 9, 16, 25. This is x0, x1, x2, x3, x4. This is y0, y1, y2, y3, y4. First I use the trapezoidal rule. The formula of trapezoidal rule is this one. Integral x0 to xn f of x dx equal to h by 2 first and last term plus y0 plus yn plus 2 into another terms y1 plus y2 plus etc. yn minus 1. So by using trapezoidal rule, integral 1 to 5 x square dx equal to h by 2, h value is 1 by 2 into y0, this is 1 plus yn, that is y4, that is 25 plus 2 into another values 4 plus 9 plus 16. Finally I got the value of this term is 42. Similarly I use Simpson's 1/3 rule. This is Simpson 1/3 rule. Integral x0 to xn f of x dx equal to h by 3 y0 plus yn first and last term plus 2 into y2 plus y4 y2, that is third ordinate, okay, odd ordinates 2 into y2 plus y4 etc. plus 4 into y1 y3 etc. So I use this rule, Simpson's 1 by 3rd rule. I got x square dx equal to 1 by 3 y0 plus yn, that is 1 plus 25 plus 2 into y2. y2 is 9 plus y4. 9 plus y4 is y0, y1, y2, y3, y4. 25. Sorry, y4 is here last term. So this is 2 plus 9, 2 into 9 plus 4 into y1 and y3. This is 4 plus 16. y4 is last term, so this is does not include in this term y4. Okay, so finally I got this calculation is 41.333. So the difference of the value of difference, absolute value of the difference between two calculations is, the difference of these two values 41.33 minus 42 is 0.6667. So rounded off two decimal places 0.67. So the final answer is 0.67. Next question. The ratio of the product of eigenvalues to the sum of the eigenvalues of the given matrix. One 3 by 3 matrix is given. You have to find the ratio of product of eigenvalues and the sum of the eigenvalues. It is a very simple question. Product by using, here I use the properties of eigenvalues. Product of the eigenvalues equal to determinant of the matrix. So first I find the product of eigenvalues equal to determinant of this matrix, that is 3 into minus 3 plus 2 cross product this 2, 3 into cancel this row and this row. I got minus 3 plus 2 and minus 1 into 2 plus 1 plus 2 into 4 plus 3. This is equal to 3 minus 3 minus 3 plus 14 equal to 8. Next, sum of the eigenvalue equal to sum of the principal diagonal elements. So, sum of eigenvalues equal to sum of the principal diagonal elements. What is principal diagonal elements? 3 minus 3 plus 1. 3 minus 3 plus 1, this is equal to 1. You have to find the ratio of product of eigenvalues to the sum of the eigenvalues. Product by sum, this is equal to 8 by 1. So, the final answer is 8. This is the final answer. Next question. Which of the following statement is are true about the function defined as f of x equal to e power minus x modulus cos x for x greater than 0? What is option? Continuous at x equal to 2 pi. Continuous at x equal to 2 pi. Differentiable at x equal to 3 pi by 2 and differentiable at any points. Okay. 4 points are given. Now, the function f of x equal to e power minus x into modulus cos x. In continuous definition says limit extends to a f of x equal to f of a, then the function f is said to be continuous. First I check the option A one is correct or not. So first I find limit f of 2 pi, this is equal to e power minus 2 pi cos 2 pi modulus cos 2 pi, this value is 1, so e power minus 2 pi. Limit x tends to 2 pi f of x, this is also e power minus 2 pi. So this function f of x equal to e power minus x modulus cos x is continuous at x equal to 2 pi because limit x tends to a 2 pi f of 2 pi, f of x equal to f of 2 pi. These two values are equal, so this function is continuous at x equal to 2 pi. Next you have to check differentiable. I check fourth option. Why? Because you know the absolute function, modulus function, absolute value of the function is not differentiable at x equal to 0. Here modulus function is available, modulus cos x. So you have to think in what value of x makes modulus cos x equal to 0. This is x equal to 3 pi by 2 and x equal to pi by 2 makes modulus cos x value equal to 0. So in these two cases it is not differentiable. So I check this only, differentiable at x equal to pi. How to check differentiable at x equal to what one value? I find that derivative of that point x equal to pi, f dash of pi. This is equal to definition x h tends to pi f of pi plus h minus f of pi by h. This is equal to f of pi limit h tends to pi, f of pi plus h is e power minus pi plus h into modulus cos of pi plus h minus e power minus pi, because f of pi is modulus cos pi is plus 1 minus 1, modulus value is plus 1, e power minus pi divided by h. H tends to pi. So finally I got the value e power minus 2 pi and e power minus pi divided by pi. Because here h tends to pi, cos 2 pi value is 1. So e power minus 2 pi, e power minus pi divided by pi. Limit exits and left hand limit and right hand limit are equal. So this function is differentiable at x equal to pi. Differentiable at x equal to pi. In other words, you can say, suppose the function f of x equal to modulus cos x, this function is not differentiable at x equal to 2n plus 1 by 2 pi. That is for all n belongs to a. Suppose you put 0, I got 1 by 2, pi, pi by 2 and 3 pi by 2, etc. Because this value of x makes modulus cos x equal to 0. Modulus function is not differentiable at x equal to 0. So modulus cos x function is not differentiable at x equal to 3 by 2 and x equal to pi by 2. That means modulus cos x function is differentiable only at r minus 2n plus 1 by 2 pi. For all n belongs to x, it is differentiable modulus cos x function. So modulus cos x function is not differentiable at x equal to 2n plus 1 by 2 pi for all n belongs to x. So you can say option 1 and 4 are true, other two are not true. So the answer is option 1 and 4. So friends, these are the engineering mathematics questions from GATE 2021 Aerospace Department question. Thank you for watching. See you in the next video. If you like this video, please like, share and subscribe my channel to encourage me. Thank you.